So on the 85 Olds, I just want to run a couple more quick tests for the idle problem. Idle speed's too high and there's a slight misfire. So we're suspecting a leaking intake manifold gasket, but I'm still not 100% sure because while running, if you undo this hose and plug it off, there isn't really that much vacuum in the crankcase. You would expect if there's a vacuum leak internally, you would get pretty substantial vacuum in the crankcase. So what else can we try? First thing, I took out all the spark plugs. Are any of the spark plugs fouled or look different? That would indicate, misfire idle if it's sucking in crankcase gases instead of air. So here are the spark plugs. They look, ACDelco R44TSX. That is the OE specified part number, and they all look pretty even. I thought they would be darker because this thing is running pig rich, but I guess at half throttle it runs pretty well. So none of the spark plugs stand out like a sore thumb. The only thing I noticed was this one, the center electrode is shifted to the left. You can see how it's way in compared to the center electrode. Like these ones, they line up pretty well. If you look head on, the center electrode is centered. This one, not so much. It's to the left. So I'm like, are these knockoff, Amazon plugs, or do they just make them like this? They're not uniform. Kind of blows my mind. All the other ones seem to be fairly centered. So nothing obvious with the spark plugs. So in the troubleshooter in the snap-on, it says adjustment spec for the TPS at closed throttle is 0.4 volts. We're at 0.6 volts. That's live data. So if I open up the TPS a little bit, 0.7, 1, that's definitely not to spec. 0.6. So this throttle stop screw up here, again, it doesn't look like it was messed with, but who knows? Maybe it was 20 years ago and it's messed up. Now the throttle plate is cracked open, I think more than it should be for a minimum idle. You see that gap is pretty substantial. So let's close up that throttle stop until we're at 0.4. We'll see if the IAC is then in a normal state. That would be pretty nuts if the throttle plate was just misadjusted. Alright, so I'm going to turn the throttle stop screw. It's a little Torx bit until we're at 0.4. So let's count the turns. We'll do half turn, one full turn, 1.5. There we go. 0.44. So 1.5 turns, and that throttle plate is definitely more closed now. Let's run it, see what the IAC does. All right, here we go. Let's fire it up. A little long crank time. So there's our IAC, RPMs, and the TPS is at 0.44 now. So let's see, as the IAC comes down, will we be in throttle control? Yes. But there is, now you can feel the misfire more. So I think what happened was it was misfiring and someone just turned up the idle screw to mask the misfire. And I thought it was all caused by one thing. So we're at 60. Let's let it warm up a little bit. It should settle down to, I don't know, 700 RPM in park. Put in gear, about 900. So it's definitely in control now, since the IAC isn't going to 0 anymore. So once it warms up, I'm sure, look at our coolant temp, we're at 170. Let's try another startup. So 150 in the IAC. Okay, a little flare up. That should drop down. Put in gear. You would think the idle would drop a little more than that, below 1,000. I don't know, maybe not. But the fact is the computer is now in control of the idle speed. We're not at 1,200, we're at 1,000, and the IAC is at 40, which is within range. TPS is at 0.46. We can even look at our integrator and block learn and our O2 sensor. So pretty close. I mean, minus 10%. That's around 128. That's the short term. That's fine. The car's happier, but it still has a partial misfire. So we should do a relative compression test and cylinder to cylinder. See which one it is. Number 6 seemed to be contributing less on the cylinder drop test. So 3 separate issues: mass airflow sensor, throttle stop screw was out, and a partial misfire. Nothing wrong with the intake manifold gasket. I'm actually glad, because I don't want to rip apart a 40-year-old intake manifold for no reason. Alright, simple setup for relative compression test. The amp clamp is around the fat starter cable. The jaws don't quite close, but we should still get a signal. 1 volt is going to be 100 amps. And then for the sync, number 1 spark plug wire, just have an inductive clamp on there. It's grounded. So 2 channels. And they're both going to be on just a 5-volt scale. See right there. Let's see if we see anything interesting. Okay. I'm going to fire it up. We don't see much on the inductive amp clamp. How do we sync this waveform? Alright, so do we see any inconsistencies in the waveform? So it's I got the scale up so we can clearly see what the pattern is, and then you want to use the active filter to kind of clean up the waveform. If we turn off the filter, it's a little fuzzy, so just bump down the frequency there until it's nice and clean. So 6 humps, and they all look pretty even. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So I mean, it might be a little higher. Let's bump up the scale here again. Those 2 are a little lower. That's like too low, high, too low, high, too low, high. Not really crazy difference or anything. And then we don't have a sync, so not a very conclusive test here. So this Oldsmobile is taking a little longer than I expected it to. So 3 separate issues. Rich condition under load, high idle, we figured those out. Now this partial misfire. It's kind of tricky. First, I want to pinpoint which cylinder is misfiring. Not so easy. We take misfire counters for granted on a scanner on modern cars. Not so with older cars. You know, we tried the relative compression test. All the peaks look pretty even. So it's either going to be air or fuel, you know, compression or something to do with the injector. The spark is fine, and the car drives really smoothly under, you know, off of idle. So it sounds like a classic low compression problem, but we didn't see any compression problems on the relative compression test. Now I want to flow test all of the fuel injectors. We have a mixed bag of injectors here. We have 4 of these green Tomco rotary disc. I've never seen anything like it. I actually looked them up online. So apparently instead of a pintle, they have some kind of disc, which is crazy. Apparently it was some kind of upgrade, but why didn't they upgrade all 6? You know, these 2 are kind of mystery injectors. So I just want to do a simple flow check. You know, energize the pump, and then pulse each one with a pulsar, see what happens. The only problem is we're not holding fuel pressure, so I'm doing some experiments here, pinching off the feed and the return line. So let's just, you know, unpinch both lines, energize the pump. It's nice that they have this bypass connector, so we can just feed fused power right to the fuel pump with the key off. So let's do that. So we have 37 psi, that's the spec. We let it go. Look at that bleed off. It just drops off a cliff, and that explains the long crank time, especially after a little hot soak. Absolutely. So it basically drops to 0 within, you know, 30 seconds or a minute. Now, how do we determine which side, you know, is it bleeding off towards the tank? Is it bleeding off through this pressure regulator? Do we have any leaks on our injectors? So we can use 2 vice grips that are, you know, won't damage the lines, and do some experiments. So first, I'm going to pinch off the return line and then energize the pump. We should see maximum pressure, so almost 65 psi, and it still drops off a cliff. So it's not the fuel pressure regulator that's at fault. Now what I want to do is energize the pump, pinch off the feed line, and see what happens. So right now both lines are pinched off, and we're still dropping pressure, not as fast, but slowly. So the only way that could happen is there's a leak somewhere in the fuel rail if the injectors are dripping. Now, I did smell the intake manifold here. It does smell a little fumey, not crazy, but again, the engine's cold right now. We're still bleeding off pretty quickly. I'm trying to use a borescope to see if we can spot any injectors that are dripping. I'm not having very good luck just because of the access to the ports. The injectors are way in there. So I think what I might do is just lift up the fuel rail, it's only 4 bolts, to see the tips of the injectors and see if any of them are dripping. This is so many things wrong. Alright, so we're actually holding steady at 35 psi. I don't see any drips on the injectors, that's good. You can see they're all different. This one's like a long nozzle, that one's a short nozzle, these are rotary types. No drips. Not a single drip. Okay, so the injectors are holding. I like that. And if I unclamp the feed line, 0. So we have a defective fuel pump check valve in the tank. That's confirmed. So we'll write that down. That's one of the problems. That's why it was starting out long crank time. That explains that. But we're still chasing this misfire. So now that we can why are we bleeding off now? Is my clamp not good enough? Let me try that again. Things are being very inconsistent here. I'm just trying to energize the pump and pinch it off and then let it stay at 35 psi. Look at that, it just drops off a cliff. Let's pinch off the return line. Uh-oh, we got a problem. There's fuel squirting out of here. What? That's not good. There's our leak. It's leaking back towards the pump. It's leaking out of this fuel pressure regulator. So we need a new one of those. I can't even do an injector flow test like this. So the customer approved brand new fuel pump, brand new fuel pressure regulator, but I still want to flow test these injectors even with the original parts installed on the car. So how are we going to do that? We need a steady fuel pressure before we pulse the injectors. So with the busted fuel pressure regulator, I took off the vacuum line and I just put a cap on here with a twisty tie. So that's, even if it's leaking through here, it's still capped off. Now, pinched off the return line, and to build fuel pressure, we just turn on the fuel pump with our jumper, release the feed line, pinch the feed line, and turn off the pump. So we're at 65 psi, rock steady. Let's pulse an injector. So injector number 1, it's nice that the pulsar tool plug fits right on there. Let's enable that. And we're starting at 63 psi. And let's see how it pulses. Okay, very nice. We dropped to 52. So I'm going to write that down and we'll repeat that for each injector. Okay, let's move to injector number 3. Again, these are the two odd ones. Energize the pump. Build some pressure. We'll do that. So it's just a very slow decay. We'll start at 63. We'll push the magic button. We'll see the injector pulse. Here we go. .52, but man, that was a stream versus the mist on the first one. We'll put that in the notes. Alright, here we go. Injector number 5. Pulse it. Ah, crap. Wrong injector. Gotta move your lead over. Try that again. Energize the pump. If the pump was good, we wouldn't need to use the pliers on there. Let that settle to 63. Right there, and I want to see how it pulses. Let's try that. Okay. Ooh, 47. Okay, injector number 2, let's pulse that one, starting at 63. 47. Alright, injector number 4. About 46, 47. So, okay, last but not least, injector number 6. Let's pulse it. 46. Injectors are all flowing fine. Let's put everything back together, start it up, run it, and see if we can pinpoint which cylinder is still not happy. Will it be a compression problem? Oh, we got another casualty here. Squeezing the hose, the return hose, unfortunately compromised it. So that rubber coating is very soft, and it just split. Joy of working on old cars, absolutely. So that's the return line. It's not a big deal. It's not under pressure, but still we need to address that before returning the car to the customer. And we couldn't have done the test for injector flow without pinching off that line. So, you know, I'll be fair with it. Obviously, maybe I won't charge them for parts, but we got to replace that hose anyways. All right, let's see how it runs. Not bad. I'm wondering if that shake is going to come back. So our fuel pressure here is 43. Obviously it's not changing because we have the fuel pressure regulator disabled. I mean, if it runs like this, I would say that'd be a win. Let's let it warm up a little bit. Oh, it's Christmas time for the 85 Oldsmobile. Check out what we got in the box. Brand new, old stock, original mass airflow sensor, AC Rochester division. I think they made carburetors. Made in the USA, Flint, Michigan. Here it is in all its beauty. Mass airflow sensor. So let's pop this in, plug in the Verus, take this thing for a test drive. I want to see the fuel trims, especially under heavy load. This sensor, if our diagnosis was correct, should make this thing drive nicely under load. No more overfueling. I hope. There could be other variables. The fuel pressure regulator is still capped off. So we're going to leave that for later. We'll fix that vacuum leak. So the fuel pressure will be a little high at idle. So at idle, when there's vacuum here, the fuel pressure should drop by 10 psi. But under load, it should still be to spec. I want to see how it performs under load. So let's pop this thing in, take it for a spin. That looks sweet. Even has mounting, put in a bolt here so it's not loosey. That's it. Let's fire up the scanner. Alright, so at idle, block learns 120, integrators 130. We're doing pretty well. Let's see how it accelerates. Oh yeah, that's what I'm talking about. That was almost full throttle. It's still in second gear here. Let's put it in overdrive. Woohoo! Nice. So the customer will be very pleased. We're almost there. This thing's driving so smooth. Love it. The block learns at 120. It's amazing. All right, let's do a full throttle acceleration here. Make sure our oxygen sensor goes rich. Great. Oh, V6 power right there. Rich, 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 rich. Awesome. Perfect. Just perfect. It's amazing how factory parts make all the difference, huh? That was our first suspicion, was aftermarket mass airflow sensor. Absolutely. So now we have to replace that fuel pressure regulator. Fix that return line so make sure it's not leaking. And the fuel pump, well, we'll see. We know there's a bleed down problem, so we'll park it, let it hot soak for like 15 minutes. If it has a hard time restarting, I'll check with the owner. I mean, I really don't want to remove the fuel tank if I don't really have to. If it drives great, it has good fuel pressure, it's just, you know, you might give it a little gas when you're starting. That's not a big deal. I wouldn't replace the fuel pump just for that. But this is really nice. And how classy is this? Just tune into the 80s station and cruise.